Millions of years ago, Earth had a very different arrangement of land and oceans. The continents were connected into one large landmass called Pangaea, which existed during the late Paleozoic and early Mesozoic eras. This enormous continent contained diverse environments, including mountains, forests, deserts, and coastal regions where many ancient organisms lived. Pangaea formed through the movement of Earth's tectonic plates and later separated as these plates continued to shift. The breakup of Pangaea created the continents that exist today and influenced global climate patterns, ocean circulation, and the development of life. Before the giant landmass known as Pangaea came into existence, the Earth had already passed through an extremely long period of change. The planet did not begin with continents, oceans, forests, rivers, or mountains that looked like those seen today. During its earliest history, Earth was a very different place. It was a young planet that was still forming after the birth of the solar system. Understanding this early period helps explain how the first continents appeared and why they eventually joined together to form larger landmasses, including Pangaea. Every continent that exists today has its roots in events that took place during this distant period of Earth's history. Earth formed about 4,540,000,000 years ago from a huge cloud of gas and dust that surrounded the young sun. Tiny grains of dust began sticking together because of gravity. As they became larger, they collided with other pieces of rock and metal. These repeated collisions slowly built larger bodies called planetesimals. Many of these early bodies crashed into one another. Over time, one of them grew into the planet that would become Earth. The process took millions of years and involved countless impacts that released enormous amounts of heat. The young Earth was not a cool and peaceful world. It was extremely hot. Heat came from many sources. The constant impacts of large rocks released energy. The pressure inside the growing planet also created heat. Radioactive elements within the Earth produced additional heat as they broke down naturally. Because of this intense heat, much of the young planet melted. Instead of having a solid surface, Earth was covered by vast areas of molten rock. This stage is often called the magma ocean because much of the outer part of the planet existed as flowing liquid rock. As the planet remained hot, heavy materials such as iron and nickel slowly moved towards the center. Lighter materials stayed closer to the surface. This process separated Earth into different layers. The center became the core, which is mostly made of iron and nickel. Around the core formed the mantle, made mainly of hot rock that can slowly flow over long periods. Above the mantle developed the crust, which became the thin outer layer of solid rock. This layered structure remains part of Earth today. The earliest crust was very different from the continents that exist now. It was thin, unstable, and often destroyed by the heat rising from below. Large cracks opened across the surface. Fresh molten rock rose through these openings and cooled. Some areas of the crust broke apart while new crust formed elsewhere. The young surface changed again and again as heat continued escaping from deep inside the planet. During this time, Earth had no permanent continents. Small pieces of solid crust formed, broke apart, melted, and formed again. The surface was constantly changing because the inside of the planet still contained enormous amounts of heat. Much of the crust could not survive for long before being recycled back into the mantle. As a result, very little rock from this earliest period remains today. The atmosphere during Earth's earliest history also looked very different from the one that surrounds the planet today. It did not contain enough oxygen for humans or animals to breathe. Instead, it was filled with gases released by volcanoes. These gases included water vapor, carbon dioxide, nitrogen, sulfur compounds, methane, and ammonia. Volcanoes were extremely common because the planet's interior was much hotter than it is today. They released huge amounts of gas into the atmosphere over millions of years. As the planet slowly cooled, water vapor in the atmosphere began turning into liquid water. Thick clouds formed around the planet. Rain fell for very long periods. Some of the rainwater collected in low areas of the surface. Over time, these growing bodies of water became the first oceans. Scientists believe that additional water may also have arrived through impacts from icy objects such as comets and water-rich asteroids. Together, these sources helped fill the oceans that covered much of the planet. The early oceans were different from those of today. They were warmer and contained different amounts of dissolved minerals and chemicals. They were influenced by frequent volcanic activity beneath the water. Hot water carrying minerals flowed from cracks in the ocean floor. These underwater volcanic systems played an important role in shaping the chemistry of the oceans and the rocks forming beneath them. Even after oceans appeared, the Earth's surface remained active. Large amounts of heat continued moving upward from deep inside the planet. This heat caused parts of the mantle to rise while cooler material slowly sank. These movements created forces that pushed and pulled the crust above. Over very long periods, these forces became responsible for the movement of Earth's outer rocky plates. This process, known today as plate tectonics, became one of the most important systems controlling the formation of continents. Scientists continue studying exactly when modern plate tectonics began. Some evidence suggests that forms of plate movement started very early in Earth's history. Other evidence suggests that the system developed gradually over hundreds of millions of years as the planet cooled. Although researchers continue examining this question, there is strong agreement that movement of the crust eventually became a major force shaping Earth's surface. The earliest pieces of continental crust began forming when molten rock cooled and hardened into lighter types of rock. These rocks contained minerals that made them less dense than the rocks beneath the oceans. Because they were lighter, they floated higher on the mantle. This allowed them to survive longer instead of sinking back into the deeper parts of the Earth. Over time, these stable pieces grew larger as more material was added to them. Some of the oldest known minerals found on Earth are tiny crystals called zircons. These crystals formed more than 4 billion years ago. Scientists study them because they preserve valuable information about conditions on the early Earth. By examining their chemical makeup, researchers have learned that liquid water probably existed very early in Earth's history. These zircons also suggest that some form of continental crust had already begun forming during this distant period. Finding rocks from the earliest Earth is extremely difficult because geological activity has recycled much of the ancient crust. Most early rocks have been melted, buried, broken apart, or changed by heat and pressure. Only a few small areas around the world still contain rocks that formed during those ancient times. These rare rocks provide important clues about how the first continents developed. As small areas of continental crust survived, they slowly joined together. New volcanic material hardened along their edges. Collisions between pieces of crust caused them to merge into larger blocks. These growing landmasses became the foundations of future continents. The process was very slow and continued over hundreds of millions of years. The early continents did not look like modern ones. Their shapes were different, and many were much smaller. They were scattered across the surface instead of forming one giant landmass. Some existed as isolated islands surrounded by wide oceans. Others formed groups of connected land. Their coastlines changed constantly because volcanic eruptions, earthquakes, and crustal movement reshaped them over time. The climate during this early period was also changing. The young sun produced less energy than it does today, yet the Earth remained warm enough for liquid water to exist. Scientists believed that greenhouse gases in the atmosphere trapped heat and helped keep temperatures suitable for oceans. Carbon dioxide and methane played especially important roles in holding warmth close to the planet's surface. Volcanic eruptions continued releasing fresh gases into the atmosphere. Lava covered wide areas of land. Ash spread across the landscape. New mountains formed where pieces of crust collided. Other mountains slowly wore down because of wind, rain, and flowing water. The broken rock was carried into rivers and eventually reached the oceans, where layers of sediment slowly accumulated. As sediments collected over long periods, they hardened into sedimentary rocks. These rocks preserved records of changing environments. They also helped build thicker sections of continental crust. Heat and pressure deep within the Earth later changed many of these rocks into metamorphic rocks. Molten rock cooled into igneous rocks. Together, these rock types became important parts of the growing continents. The movement of Earth's crust caused repeated cycles of growth and destruction. Some pieces of continental crust collided and joined together. Others split apart because of forces pulling the crust in different directions. Ocean basins opened and later closed. Mountains rose and gradually wore away. Throughout all these changes, the amount of continental crust slowly increased. The first continents were not lifeless for their entire history. At some point during Earth's early development, simple microscopic life appeared. Scientists continue studying exactly how life began, but evidence suggests that tiny living organisms existed at least 3,500,000,000 years ago and possibly even earlier. These early forms of life lived mainly in the oceans. They were single-celled organisms with very simple structures. Many of these tiny organisms obtained energy through chemical reactions involving substances found in the water. Later, some groups developed the ability to use sunlight to produce food through photosynthesis. Early photosynthesis gradually released oxygen into the oceans and eventually into the atmosphere. At first, much of this oxygen reacted with iron dissolved in seawater. These reactions formed iron-rich rocks that can still be found today. Over very long periods, oxygen slowly accumulated in the atmosphere. This major environmental change transformed Earth's surface. It affected the chemistry of rocks, oceans, and the atmosphere itself. Many early organisms could not survive rising oxygen levels, while others adapted to the changing conditions. This shift became one of the most important events in Earth's biological history. As continents continued growing, they influenced weather patterns, ocean currents, and the movement of nutrients across the planet. Rivers carried minerals from the land into the oceans. Coastal environments developed where land met the sea. Shallow waters provided places where sediments gathered and living organisms thrived. The interiors of the growing continents contained ancient rocks that became increasingly stable. These regions are known today as cratons. Cratons form the oldest and strongest parts of modern continents. Many have survived for billions of years despite repeated geological activity around them. They acted as long-lasting foundations upon which younger rocks were later added. Different cratons slowly expanded as volcanic activity and continental collisions attached new material to their edges. Each addition increased the size of the continents. Some new rocks formed from cooled magma rising from below. Others were pieces of crust carried by moving plates, including changes in water levels, oxygen availability, and temperature. The development of early ecosystems on land was closely connected to the spread of plants. Earlier, land plants were small and usually grew close to moist areas, but new plant groups developed stronger structures that allowed them to grow taller. Plants with stems and internal transport systems became more successful in different environments. They could spread farther away from water sources and begin forming more complex plant communities. These developing plant communities changed the appearance of land surfaces. Areas near rivers and wetlands began to contain larger groups of plants. The presence of vegetation created new habitats for small animals. Insects and other arthropods could live among plants, feed on plant material, and use vegetation for protection. The first forests began developing during the Devonian period. These early forests were not like modern forests, because they contained different types of plants and lacked many of the trees found today. However, they represented a major change in Earth's ecosystems. Large plants created new structures on land and provided environments where many organisms could survive. Early forests included plants such as ancient tree-like forms and large vascular plants. Some of these plants grew several meters tall. Their roots interacted with soil and rocks, increasing the development of soil layers. As plants died and decomposed, they added organic material to the ground, improving conditions for future plant growth. The growth of vegetation also influenced the carbon cycle. Plants removed carbon dioxide from the atmosphere through photosynthesis and stored carbon in their tissues. When plant material became buried instead of completely decomposing, some carbon remained trapped in Earth's crust. Over very long periods, this process contributed to the formation of coal deposits that became important geological resources. The expansion of plants affected the atmosphere by increasing oxygen production. During the late Paleozoic, oxygen levels continued changing because of the balance between plant growth, decomposition, volcanic activity, and other natural processes. Higher oxygen levels created conditions that allowed some land animals to grow larger than earlier forms. Insects and other arthropods were among the organisms that benefited from expanding land environments. Early insects developed during this broad period and became more diverse as plants spread. They developed different ways of feeding, moving, and surviving in terrestrial habitats. Some lived among plants, while others occupied soil environments or areas near water. The development of land ecosystems also created new relationships between organisms. Plants provided food and shelter, while animals affected plant growth by feeding on vegetation and spreading plant material. These interactions helped shape the structure of early terrestrial communities. Amphibians became another important group during the late Paleozoic. Their ancestors developed from fish groups that had features allowing them to survive in shallow waters and eventually move onto land. The transition from aquatic life to life on land was gradual and involved many changes in body structure. Early amphibians still depended heavily on water. They needed moist environments for reproduction because their eggs lacked protective coverings that allowed them to develop away from water. Many early amphibians lived near rivers, lakes, and wetlands where they could move between aquatic and terrestrial habitats. The development of amphibians showed that vertebrate life was becoming more diverse. Animals with backbones were no longer limited to marine environments. New challenges appeared on land, including supporting body weight, breathing air, and moving across solid surfaces. Reptile ancestors appeared later in the Paleozoic as some vertebrates developed adaptations that allowed them to become less dependent on water. One important development was the evolution of eggs with protective coverings. These eggs allowed embryos to develop in environments away from water, giving reptiles greater freedom to live in dry areas. The changing environment of the late Paleozoic created opportunities for many new forms of life. As continents shifted and ecosystems expanded, different groups of organisms adapted to different habitats. Some remained in oceans while others moved into freshwater environments or spread across land. The oceans continued to experience major changes during this period. Marine ecosystems remained highly diverse, containing many groups of animals. Fish continued evolving, and new types of jawed fish became successful predators and swimmers. Armored fish groups became especially important during the Devonian period. Marine invertebrates also remained common. Trilobites, brachiopods, mollusks, and other groups continued living in ocean environments. Reef systems supported many species by providing areas for feeding, protection, and reproduction. However, marine ecosystems also experienced environmental pressures. Changes in sea levels, ocean chemistry, and climate conditions affected many species. The late Devonian period included several extinction events that caused the decline of some marine groups. These events were connected to environmental changes involving ocean conditions, climate shifts, and reduced oxygen levels in some marine areas. Sea level changes were common during the Paleozoic era. The amount of water stored in ice, the movement of continents, and changes in ocean basins influenced global sea levels. When sea levels rose, shallow seas expanded across continental areas. When sea levels dropped, large areas of seabed became exposed. These changes affected where organisms could live. Marine animals adapted to changing coastlines, while land organisms experienced changes in available habitats. Coastal regions were especially important because they contained environments where marine and terrestrial systems interacted. Geological activity continued influencing the planet. Volcanic eruptions released gases, ash, and minerals. These materials could affect local environments and contribute to long-term changes in the atmosphere. Volcanic activity was also connected to the movement of tectonic plates. Mountain formation increased in some regions as continents moved toward each other. When continental areas collided, layers of rock were compressed and pushed upward, forming mountain ranges. These mountains affected erosion, river systems, and climate patterns. The breakdown of rocks through weathering became an important process during this time. Rain, wind, temperature changes, and biological activity slowly damaged exposed rocks. The materials produced by weathering were transported by rivers and deposited in new locations. This process helped create new soils and changed landscapes. Climate conditions continued changing throughout the late Paleozoic. Warm periods were interrupted by regional cooling events. The movement of continents toward polar regions affected temperature patterns. Areas located near the poles experienced different conditions from tropical regions. The relationship between climate and life became increasingly important. Changes in temperature, rainfall, and atmospheric conditions influenced which plants and animals could survive in particular areas. Organisms that adapted successfully to changing environments continued developing, while others declined. The atmosphere of Earth during this time was controlled by many connected processes. Volcanic activity added gases, oceans absorbed and released gases, rocks removed carbon dioxide through chemical reactions, and living organisms changed atmospheric composition through biological activity. The increasing spread of plants had a major effect on these processes. More vegetation meant more carbon dioxide removal through photosynthesis. Plant growth also affected soil formation and water movement across continents. These changes gradually altered the relationship between Earth's surface and atmosphere. The late Paleozoic world continued developing through interactions between geology, climate, oceans, and living organisms. Continents moved into new positions. Oceans changed shape, plants expanded across land, animals developed new abilities, and atmospheric conditions continued to shift. These processes shaped the environments that existed during the later parts of the Paleozoic era. Around 419 million years ago, the Earth entered a new period in its long geological history, known as the Devonian period. This period lasted until around 359 million years ago, and was part of the larger Paleozoic era. During this time, major changes took place in the oceans, on land, and in the atmosphere. The Devonian period became a time when fish groups expanded greatly, new marine animals appeared, and plants began to spread across the continents. It was also the period when some vertebrates began important changes that later allowed their descendants to live on land. At the beginning of the Devonian period, the Earth was not arranged in the same way as it is today. The continents were located in different positions, and large areas of land were connected together in ways that no longer exist. The southern part of the planet contained a large landmass called Gondwana, which included areas that would later become parts of Africa, South America, Antarctica, Australia, and other regions. Other smaller continents and land blocks existed closer to the equator. The movement of these landmasses continued throughout the Devonian period because of the slow movement of Earth's tectonic plates. The oceans covered large areas of the planet and contained many forms of life. Marine environments were especially important because most animal life still lived in water. Fish groups were becoming more diverse, and many new forms developed different body structures, feeding methods, and ways of surviving. The Devonian period is often connected with the great expansion of fish, because many important fish groups became widespread during this time. Among the most successful fish of the Devonian period were armored fish known as placoderms. These animals had protective plates covering parts of their bodies, especially their heads and front sections. The armor was made from hard materials that helped protect them from attacks by other animals. Placoderms lived in many marine environments, including shallow coastal waters, reefs, and deeper ocean areas. Early placoderms were generally small and had simple body forms, but over millions of years, some groups developed into larger and more powerful predators. One of the most famous Devonian predators was Dunkleosteus, a large placoderm that lived during the later part of the Devonian period. It had a strong head covered with thick armor and powerful jaws formed from sharp, bony plates. These structures allowed it to capture and cut through other animals. Dunkleosteus was not a true shark and did not have modern teeth. Instead, it used sharpened parts of its jaw plates to seize prey. Fossils show that some species of Dunkleosteus reached several meters in length. It lived in oceans where it hunted other fish, smaller placoderms, and various marine animals. Its powerful body structure shows the level of development reached by some armored fish during the Devonian period. Other placoderm groups developed different lifestyles. Some lived close to the ocean floor and searched for small animals hidden in sediments. Others moved through open water and hunted active prey. Their different body shapes allowed them to occupy different environments, which helped them become successful in Devonian seas. The Devonian oceans also contained early sharks and their relatives. These animals belong to groups of cartilaginous fish, meaning their skeletons were made mainly of cartilage instead of bone. Cartilage is a flexible material found in modern sharks and rays. Fossils from Devonian rocks show that early shark relatives already had important features that helped them survive in marine environments. Early sharks were generally different from modern sharks, but they shared some important characteristics including streamlined bodies and strong swimming abilities. They lived alongside armored fish and other marine predators. Their presence shows that several groups of fish were developing different methods of survival during this period. The oceans of the Devonian period contained many other animals besides fish. Coral reefs developed in many shallow marine areas and provided living spaces for numerous creatures. These reefs were formed by organisms that produced hard structures, creating areas where many animals could find shelter and food. Brachiopods, mollusks, trilobites, and other invertebrates remained common in marine environments. The growth of fish diversity was connected to changes in ocean environments. Different habitats provided opportunities for animals to develop new forms and behaviors. Some fish became specialized for hunting, while others developed features that helped them feed on plants, small animals, or organic material found in the water. During the Devonian period, fish with jaws became especially successful. The development of jaws was an important event in vertebrate evolution because it allowed animals to capture and process a wider variety of food. Jawed fish could become active predators and compete for resources in different environments. Many later vertebrate groups descended from early jawed fish. Another important group of Devonian fish was the lobe-finned fish. These fish had strong fins supported by bones and muscles. Their fins were different from the thin, flexible fins of many other fish groups. The internal structure of their fins later became important in the evolution of animals that moved onto land. Lobe-finned fish lived in freshwater areas such as rivers, lakes, and wetlands, as well as some marine environments. Some species developed body features that helped them survive in shallow waters where conditions could change. These adaptations became important because some descendants of these fish eventually developed the ability to move in land environments. The Devonian period was also a major time for the development of plants on land. Before this period, land plants existed but were generally small and limited in size. During the Devonian, plants became larger, more complex, and more widespread. They began changing the appearance of many land areas and created new environments for other organisms. Early land plants developed structures that helped them survive outside water. They evolved stronger tissues for support, systems for moving water and nutrients, and reproductive methods that allowed them to spread across larger areas. These changes allowed plants to grow taller and form more complex communities. One important development during the Devonian period was the appearance of early forests. These forests were not like modern forests with large trees and many layers of vegetation, but they contained taller plants that formed dense groups in suitable environments. Some of the earliest tree-like plants belong to groups such as cladoxylopsids and early lycophytes. The appearance of forests changed land environments in several ways. Plant roots helped break down rocks and form deeper soils. As plants died and decomposed, they added organic material to the ground. This helped create conditions where more plants could grow. The spread of vegetation also provided new habitats for small land animals. One of the earliest known forests developed during the Devonian period in what is now the region of Gilboa in New York State, United States. Fossils from this area show that tree-like plants were already growing in groups around 385 million years ago. These plants had tall structures and root systems that helped them remain stable. The growth of forests also affected the atmosphere. Plants absorbed carbon dioxide through photosynthesis and released oxygen. Over long periods, increasing plant growth influenced the chemical conditions of the atmosphere. The expansion of vegetation also affected the movement of water on land, because roots helped hold soil and influenced the flow of rivers and streams. Land plants continued to diversify throughout the Devonian period. Lycophytes, ferns, and other early plant groups became more common. Some plants developed reproductive structures that allowed them to spread more effectively. The development of seeds also began during the Devonian, creating new possibilities for plant survival in different environments. The first seed-producing plants were small compared with many later plants, but their development was important. Seeds allowed plants to protect young embryos and spread to areas where water was not always available for reproduction. This helped plants expand into new habitats. The spread of plants created new opportunities for animals. As vegetation increased, insects and other small land organisms began using these environments. Although land ecosystems were still developing, the presence of more plants provided food sources and shelter for early land animals. The Devonian period was also important because vertebrates began making greater use of land environments. The first vertebrates were fish, but some groups developed features that allowed them to survive outside water for short periods. These changes did not happen suddenly. They developed gradually over millions of years through many stages. Some shallow water fish lived in environments where water levels changed regularly. They experienced conditions where they needed to move through muddy areas, survive with lower oxygen levels, or travel between small pools. These conditions created pressure for certain fish groups to develop stronger bodies and new methods of movement. Lobe-finned fish were among the groups that developed features connected to early land movement. Their fins contained bones arranged in ways that were more similar to the limbs of later land vertebrates. These structures allowed them to support their bodies better and move through shallow water environments. One important example of this transition is Tiktaalik, a fish-like animal that lived during the later Devonian period, around 375 million years ago. Fossils of Tiktaalik were discovered in the Canadian Arctic. It had characteristics of both fish and early land vertebrates. It possessed fins with strong internal bones, a flexible neck, and features that helped it support itself in shallow environments. Tiktaalik still lived mainly in water, but its body showed changes that were important in the development of animals that could move onto land. Its discovery helped scientists understand the gradual changes that occurred between ancient fish and early four-legged vertebrates. The transition from water to land involved many physical changes. Early vertebrates needed stronger skeletons to support their bodies without the support of water. They also needed changes in breathing systems, movement, senses, and reproduction. These changes developed slowly across many generations. The development of early land vertebrates continued during the later part of the Devonian period, as certain fish groups became better suited for life in shallow water environments connected to land. These animals were not fully land animals, but they had features that allowed them to spend short periods outside water. Their bodies provide evidence of the early stages of one of the most important changes in vertebrate history. One of the major challenges faced by early vertebrates moving toward land was breathing. Most fish depend on gills that extract oxygen from water. Some Devonian fish developed additional breathing abilities that helped them survive in environments where oxygen levels in water could become low. Certain lobe-finned fish developed structures connected to air breathing, and these adaptations were useful in warm, shallow waters, temporary pools, and areas where water conditions changed. The development of stronger fins was also important. Many fish use their fins mainly for controlling movement while swimming, but the fins of some lobe-finned fish contained bones arranged in a way that provided greater support. These stronger fins helped animals push against the bottom of shallow waters and move through muddy areas. Over long periods, these structures became more similar to the limbs of early land vertebrates. The first four-limbed vertebrates, known as tetrapods, appeared near the end of the Devonian period. Their early members were still closely connected to aquatic environments. They lived in areas such as rivers, lakes and wetlands, where they could return to water when necessary. Their bodies had features that allowed them to support themselves better and move through shallow habitats. One of the earliest known tetrapods was Acanthostega, which lived around 365 million years ago. Fossils of this animal show that it had limbs with digits. However, its limbs were not built like those of later land animals, and it was probably better suited for movement in water rather than walking on dry land. Its existence shows that the first stages of limb development happened before animals became fully adapted to life on land. Another early tetrapod was Ichthyostega. It lived during the late Devonian period and had stronger limbs than earlier forms. It had features that allowed it to support its body more effectively, although it still depended heavily on aquatic environments. These animals show that the transition from fish to land vertebrates involved many intermediate stages. The movement of vertebrates into land environments was connected to the changing conditions of Devonian ecosystems. Expanding forests created new habitats, while rivers and wetlands provided areas where early vertebrates could find food and shelter. The presence of plants on land also supported the growth of small animal communities. Insects and other small land organisms began appearing during the Devonian period. These early land animals were still limited compared with later groups, but their presence created new relationships between plants and animals. Small arthropods moved among plants, fed on organic material, and contributed to the development of early land ecosystems. The growth of forests also influenced the formation of freshwater habitats. Plant roots affected the structure of soils and changed the way water moved across land. Rivers carried nutrients from land into aquatic environments, creating productive areas where fish and other organisms could live. Devonian forests contained several types of plants. Some were related to later ferns, while others belonged to groups that no longer exist today. These plants developed different methods of growth and reproduction. Some produced spores, while others began developing seeds. Their spread across continents increased the complexity of land environments. Large tree-like plants developed internal support systems that allowed them to grow higher than earlier land plants. They also developed deeper root structures that helped them obtain water and nutrients. These changes allowed vegetation to survive in different locations, including areas farther away from constant water sources. The expansion of plants had effects on soil formation. Before extensive plant growth, many land surfaces had limited soil development. Plant roots broke apart rocks, trapped sediments, and added organic material when plant parts died. Over time, these processes created richer soils that supported more plant growth. The Devonian period also experienced important changes in climate. The climate was generally warm, but conditions varied across different regions of the planet. Some areas had tropical conditions, while others experienced different seasonal patterns. The growth of plants influenced local environments by changing moisture levels and creating shaded areas. The oceans of the Devonian period continued to support a wide variety of predators. Armored fish remained important, but other predators also developed. Early sharks, jawed fish and large invertebrates occupied different positions in marine food systems. These animals competed for resources and influenced the development of other species. The diversity of marine predators increased pressure on prey animals. Some fish developed stronger armor, faster swimming abilities, or improved senses to survive. Others developed different body shapes that helped them avoid predators or find food more effectively. These changes contributed to the wide range of fish forms found in Devonian fossil records. Placoderms remained among the dominant marine vertebrates during much of the Devonian period. Some species lived in shallow coastal waters, while others occupied deeper marine areas. Their success lasted for millions of years, but many placoderm groups disappeared during the mass extinction event that occurred at the end of the Devonian period. The Devonian oceans also contained ammonoids, which were relatives of modern squids and octopuses. These animals had coiled shells and were active swimmers. They became important marine organisms and spread into many ocean environments. Their fossils provide information about Devonian marine conditions. Coral reef communities continued developing during this period. Reef systems supported many animals by creating areas where different species could hide, reproduce, and search for food. Fish often gathered around these environments because they provided access to smaller organisms and protection from open water predators. The Devonian period was also a time when insects began important early developments. Fossil evidence shows that some of the first insects appeared during this period. These early insects were small and simple, but they represented the beginning of a major group of land animals that would later become highly diverse. The relationship between plants and insects became increasingly important. Plants provided food and shelter, while insects interacted with vegetation in different ways. Although flowering plants did not exist during the Devonian period, early plant communities already supported small animal populations. Freshwater environments were especially important in the development of early vertebrates. Rivers and lakes provided areas where fish could experience changing conditions. These environments often contained shallow waters, muddy surfaces, and areas with plant growth. Such locations created opportunities for animals with stronger bodies and improved movement abilities. The end of the Devonian period was marked by major environmental changes. Several extinction events occurred during the later Devonian, affecting many marine organisms. Changes in ocean conditions, climate patterns, and oxygen levels contributed to the decline of many species. One major extinction event occurred near the boundary between the Devonian and the following Carboniferous period, around 359 million years ago. Many groups of marine animals were affected, including several types of fish and reef-building organisms. The exact causes were complex and involved several environmental factors. Despite these losses, important evolutionary developments from the Devonian period continued into later geological periods. Early forests continued expanding, land vertebrates continued changing, and fish groups that survived remained important parts of aquatic ecosystems. The Devonian period recorded major changes in the history of life. The oceans contained highly developed fish communities with armored predators, early sharks, and many other marine animals. The continents developed larger plant communities and forests began appearing in several regions. Vertebrates began developing features that allowed them to explore land environments. The fossils preserved from this period provide evidence of these changes. Fossilized bones, plant remains, tracks and marine deposits allow scientists to study the conditions that existed hundreds of millions of years ago. These discoveries reveal how living organisms responded to changing environments and how new forms developed over long periods of time. The Carboniferous period was one of the most important periods in the history of life on Earth. It lasted from about 359 million years ago to about 299 million years ago. During this long period, the surface of the planet experienced major changes in climate, land formation, plant development, and animal life. Large areas of Earth became covered by thick forests that grew in warm and wet environments. These forests contained many types of plants that were different from the plants found today. They grew across wide regions and created ecosystems that supported many animals, especially insects, amphibians, and early reptiles. The name Carboniferous comes from the large amount of carbon stored in the rocks that formed during this period. Much of this carbon came from dead plants that accumulated in wet environments and were later changed into coal over millions of years. The coal deposits formed during this time became important natural resources much later in Earth's history. The plants that lived during the Carboniferous period removed carbon dioxide from the atmosphere and stored carbon inside their tissues. When these plants died and became buried under layers of soil and water, the carbon remained trapped and slowly became part of coal deposits. During the Carboniferous period, Earth's continents were arranged differently from their present positions. Several large land areas were moving toward each other, and this movement eventually contributed to the formation of the supercontinent called Pangaea. The positions of continents affected climate conditions, ocean currents, and the distribution of plants and animals. Some areas near the equator had warm and humid conditions that allowed large forests to grow. Other regions were cooler and drier, where different types of plants and animals developed. The forests of the Carboniferous period were mainly found in lowland areas where water was abundant. Many of these regions were covered by swamps, rivers, and shallow lakes. The constant presence of water helped plants grow quickly and allowed large amounts of plant material to collect after plants died. Because these environments had limited oxygen in the waterlogged soil, dead plants did not completely decay. Instead, layers of plant remains built up over time. These layers later became peat and eventually transformed into coal. The ancient forests of this period contained plants that reached large sizes. Many of these plants were not flowering plants because flowering plants had not yet evolved. Instead, forests were dominated by groups such as lycophytes, horsetails, ferns, and seed plants. Some lycophytes grew into tall trees with strong trunks and large leaf structures. These trees could reach heights of more than 30 meters in some environments. Their remains contributed greatly to the formation of coal because they produced large amounts of plant material. One important group of Carboniferous plants was the giant lycophytes. These plants were related to smaller club mosses that exist today, but the ancient forms were much larger. Trees such as Lepidodendron and Sigillaria had tall, straight trunks covered with patterns left by their leaves. Their roots spread through swampy soil and helped them absorb water from the ground. These plants grew in large groups and formed extensive forests across many regions. Another important plant group was the giant horsetails. Ancient horsetails included plants such as calamites, which had tall, hollow stems. Some calamite species grew several meters high and formed dense areas near rivers and wetlands. Their structure allowed them to grow quickly in areas where water was plentiful. When these plants died, their remains became part of the layers of organic material that later formed coal. Ferns were also common in Carboniferous forests. Many ferns grew as large plants with wide leaves. They occupied different parts of the forest environment, including areas close to water and places with more open sunlight. Some fern-like plants developed seeds, which helped them spread into new areas. Seed plants became increasingly important because their seeds allowed them to survive in environments where water was not always available for reproduction. The forests of the Carboniferous period supported complex ecosystems. Plants provided food and shelter for many animals. Insects lived among the leaves, stems, and decaying plant material. Amphibians moved through the wetlands, feeding on smaller animals. Early reptiles began developing adaptations that allowed them to spend more time away from water. These changes represented important steps in the history of land animals. The atmosphere during the Carboniferous period had a higher oxygen level than the present atmosphere. The large amount of plant growth contributed to this condition because plants released oxygen through photosynthesis. At the same time, the burial of plant material reduced the amount of carbon dioxide in the atmosphere. These changes affected the climate and influenced the size and activity of many animals. One of the most famous features of the Carboniferous world was the presence of giant insects. The higher oxygen levels allowed some insects to grow larger than most insects living today. The bodies of insects depend on a system of small tubes that carry oxygen directly to their tissues. The greater amount of oxygen in the atmosphere helped some insects reach sizes that would be difficult under modern atmospheric conditions. One well-known giant insect from this period was Meganura. It was a large flying insect related to modern dragonflies. Its wings could stretch more than 60 centimeters across. Meganura lived around forests and wetlands where it hunted smaller insects and other animals. Its large size made it one of the largest flying insects known from Earth's history. Other large insects also lived during the Carboniferous period. Giant millipede relatives such as Arthropleura moved across forest floors. Arthropleura was one of the largest land invertebrates ever known. It could grow several meters long and lived in humid forest environments. It fed mainly on plant material and decaying vegetation. Its size was supported by the environmental conditions of the time, including abundant food sources and higher oxygen levels. The forest also supported many amphibians. Amphibians were among the most common land animals during the Carboniferous period. They lived in areas with rivers, lakes, and swamps because they depended on water for reproduction. Many Carboniferous amphibians were larger than most modern amphibians. Some species reached lengths of several meters. The amphibians of this period belong to different groups, including temnospondyls and lepospondylls. Temnospondyls were a diverse group that included many large species. Some had strong bodies and powerful jaws used for catching fish and other animals. Others were smaller and fed on insects and small creatures living in the forest environment. The wet forests provided ideal conditions for amphibians because there were many places where they could lay eggs and find food. The shallow waters contained fish, small aquatic animals, and insect larvae. The forest floor contained many insects and other small animals that became food sources for amphibians. During the later part of the Carboniferous period, early reptiles became more common. Reptiles developed features that allowed them to live farther from water than amphibians. One important development was the evolution of the amniotic egg, which contained protective layers that allowed embryos to develop on land. This reduced the need for reptiles to return to water for reproduction. Early reptiles were generally small compared with many amphibians of the time, but they were important because they represented a major change in land animal development. They could explore drier environments and survive in places where amphibians had difficulty living. Their descendants later developed into many different groups of reptiles. The Carboniferous forests were also home to early forms of spiders, scorpions, and other arthropods. These animals lived among the plants under fallen leaves and in the soil. They played important roles in breaking down dead plant material and recycling nutrients through the ecosystem. The large amount of plant growth during the Carboniferous period created conditions that were different from many earlier periods. Plants had developed stronger structures that allowed them to grow taller and spread across larger areas. Their roots helped change the soil by breaking down rocks and adding organic material. These changes affected the development of terrestrial ecosystems. The growth of forests also influenced the movement of water across the land. Plant roots helped hold soil together and affected the way rivers and wetlands developed. Large swamp regions became areas where plant material could collect for long periods. These environments were responsible for creating many of the coal deposits that are found today. The process of coal formation began with the growth and death of plants in wet environments. When trees, ferns, and other plants died, they fell into swamps where water covered them. The lack of oxygen slowed decomposition. Over time, more layers of dead plants accumulated on top of older layers. Pressure from these layers compressed the plant material. The first stage of this process produced peat, which is a dark material made from partially decomposed plant remains. As more sediment covered the peat, pressure increased and water was removed. Over millions of years, chemical changes transformed the peat into coal. Different types of coal formed depending on the amount of pressure, heat, and time involved in the process. The coal deposits created during the Carboniferous period were especially large because forests covered wide areas for millions of years. Repeated cycles of forest growth, flooding, burial, and sediment accumulation created thick layers of organic material. These layers were preserved in rocks that formed during the period. Coal deposits from the Carboniferous period are found in many parts of the world. They formed in regions that were once tropical swamp forests. Areas that are now located in Europe, North America, and parts of Asia contain important coal beds that developed from Carboniferous plant remains. The locations of these deposits show how much the continents have moved since that time. The formation of coal deposits during the Carboniferous period was connected to the repeated changes that occurred in ancient swamp environments. These forests did not remain exactly the same for millions of years. The landscape changed because of rising and falling sea levels, movements of the land, changes in rivers, and variations in climate. These events created new wetlands where plants could grow, and new areas where dead plant material could become buried. Many Carboniferous coal deposits formed in areas called coal swamps. These were low-lying regions where water collected easily. The ground remained wet for long periods, creating conditions where plant remains could accumulate faster than they could break down. As new generations of plants grew and died, layers of organic material became thicker. Sediments from rivers and floods sometimes covered these layers, protecting them from complete decay. The forests of this period were not silent or empty environments. They contained many interactions between plants, animals, fungi, and microorganisms. Insects fed on plants, amphibians hunted insects, and decomposers broke down dead material. These activities affected how organic material was recycled within the forest. When plant remains were buried quickly in wet conditions, some of the carbon remained trapped instead of returning to the atmosphere. The structure of Carboniferous forests was different from modern forests because many of the dominant plants belonged to groups that later declined. Large tree-sized lycophytes were especially common in swamp regions. Their tall trunks and shallow root systems allowed them to grow in wet soils. When these forests died, their remains created thick layers of plant material that became important sources of coal. The leaves and branches of these plants also contributed to the organic layers. Fallen plant parts collected on the swamp floor and mixed with water, mud, and other materials. The constant addition of new material created deep deposits that were later buried beneath layers of rock. The transformation from plant remains into coal happened slowly over geological time. Different types of coal formed from different levels of change. Some deposits remained closer to their original plant structure and became materials such as peat. Other deposits experienced greater pressure and heat, causing them to become forms of coal with higher carbon content. The process depended on the conditions underground after burial. The burial of plant material also affected Earth's atmosphere. Plants absorbed carbon dioxide during growth and stored carbon inside their bodies. When large amounts of plant material became buried instead of decomposing, carbon was removed from the active carbon cycle for long periods. This contributed to changes in atmospheric composition during the Carboniferous period. The climate of the Carboniferous period was not the same everywhere. Tropical regions contained extensive forests, while other areas experienced cooler conditions. During the later part of the period, parts of the southern continents were affected by glaciation. Large ice sheets developed in some southern regions, causing changes in sea levels and affecting coastal environments. The presence of glaciers in some regions influenced the distribution of plants and animals. Areas that became colder supported different types of vegetation than the warm tropical forests. Some plants were limited to specific environments, while others spread into new regions where conditions were suitable. The Carboniferous period contained several environmental zones. Tropical swamp forests existed near the equator, while drier regions contained plants adapted to lower water availability. Mountains, rivers, coastlines, and inland areas all supported different communities of living organisms. The animals of the Carboniferous forests adapted to these different environments. Amphibians living near water developed various body forms and hunting methods. Some were active predators that caught fish and smaller animals. Others were smaller species that searched through vegetation and soil for insects and other food sources. The development of large amphibians was related to the abundance of aquatic habitats. Rivers, lakes, and swamps provided places for reproduction and feeding. Some amphibians had strong jaws and large bodies that allowed them to capture larger prey. Fossils show that these animals were widespread in many regions during the period. The Carboniferous also saw the growth of early tetrapod diversity. Tetrapods are animals with 4 limbs or descendants that evolved from 4-limbed ancestors. The period was important because different groups were developing new ways of living on land. Some remained closely connected to water, while others became more suited for life in drier areas. Early reptiles developed features that helped them survive away from permanent water sources. Their skin reduced water loss, and their eggs provided protection for developing young. These changes allowed reptiles to explore environments that were less suitable for amphibians. The forests provided many hiding places for small reptiles. Fallen leaves, tree roots, and plant remains created spaces where these animals could search for insects and avoid larger predators. Their ability to survive in different habitats contributed to the later expansion of reptile groups. Insects were among the most successful animals in carboniferous forests. They occupied many ecological roles, including plant feeding, hunting, and breaking down organic material. The forests provided large amounts of food and shelter, allowing insect populations to increase. Giant dragonfly relatives such as Meganura were active predators in the air. They used their wings to move through forest areas and catch smaller flying animals. Their large bodies were supported by the environmental conditions of the period. Other flying insects also developed during this time. Early relatives of cockroaches, beetles, and other insect groups lived among the plants. Many of these insects fed on leaves, decaying vegetation, fungi, and other organic materials. The forest floor contained large arthropods as well. Arthropleura moved through damp areas covered with plant remains. Its body was protected by hard, outer plates, and it used many legs to move across the ground. It mainly consumed plant material and contributed to the breakdown of vegetation. The size of some carboniferous arthropods was influenced by several environmental factors. The atmosphere contained more oxygen than today, and food resources were widely available in many forest regions. These conditions supported animals that required large amounts of oxygen for their bodies. The Carboniferous period also included important developments among plants that produced seeds. Seed plants became increasingly successful because they could reproduce without depending entirely on wet environments. This allowed them to spread into areas that were not covered by swamps. Some seed plants developed protective structures around their seeds. These adaptations helped young plants survive in changing environments. Over time, seed plants became more common in many parts of Earth. The plant communities of the Carboniferous affected the development of soils. As roots grew into the ground, they broke apart rocks and added organic matter. Dead roots and fallen leaves contributed nutrients to the soil. These processes changed the surface environments where plants and animals lived. The remains of Carboniferous forests are preserved in fossil records. Fossil tree trunks, leaves, spores, and roots provide information about ancient environments. Scientists study these remains to understand how plants grew and how climate conditions changed during the period. Fossilized spores are especially useful for studying Carboniferous vegetation. Many plants reproduce through spores instead of seeds. These tiny structures could travel through wind and water, spreading plants across large areas. Their presence in rocks helps scientists identify ancient environments. The rocks formed during the Carboniferous period also contain evidence of ancient rivers, lakes, and coastal regions. Sedimentary rocks preserve layers of material that show how landscapes changed over time. These geological records provide information about the environments where coal forests developed. The creation of coal was not limited to one single event. It happened through many cycles over millions of years. Forests grew, died, became buried, and were transformed underground repeatedly. Each cycle added new layers of organic material to Earth's geological record. The coal produced from Carboniferous forests later became important because it stored large amounts of energy from ancient plants. The carbon inside these deposits remained preserved underground for hundreds of millions of years before humans discovered and used them. Around 400 million years ago, during the Devonian period, Earth experienced major changes that affected the development of life on land. At this time, plants that had previously lived mostly in shallow water environments began spreading into new areas across the continents. The land surfaces of Earth were changing, and new types of vegetation started appearing in places where only small plants had existed before. These changes created new environments that allowed more complex forms of life to survive away from oceans and rivers. During the early Devonian period, most land plants were still small and simple compared with later plants. Many had thin stems and lacked the strong internal structures needed to grow very tall. However, over millions of years, plants developed new features that allowed them to spread widely across land. They developed stronger stems, deeper roots, and improved ways to transport water and nutrients. These changes allowed plants to grow larger and survive in different environments. One of the most important developments was the appearance of vascular plants. These plants had special internal tissues that moved water and nutrients throughout their bodies. This allowed them to grow higher above the ground and reach sunlight more effectively. The development of vascular systems changed the way plants lived because they were no longer limited to very wet areas. They could expand into drier locations and occupy more parts of the continents. During the Devonian period, forests began to develop for the first time in Earth's history. These early forests were very different from modern forests, but they contained large plants that formed areas of dense vegetation. Some of the earliest trees belonged to groups such as the Cladoxylopsids and Archaeopterids. These plants grew several meters tall and created habitats that had not existed before. The appearance of early trees changed the surface of Earth. Tall plants provided shade, shelter, and new sources of food for many organisms. Their roots also affected the soil by breaking rocks into smaller pieces and helping form deeper layers of soil. As plants died and became buried, they added organic material to the ground. This process improved soil quality and supported the growth of more plants. The roots of these early forests also affected rivers and landscapes. Before large plants existed, many land surfaces experienced more erosion because there were fewer roots holding soil together. As forests expanded, plant roots helped stabilize the ground. This influenced the movement of water across continents and changed the appearance of many environments. The Devonian forests developed mainly in regions that had suitable temperatures and enough moisture. At this time, the continents were arranged differently from today. Large land areas were located closer to the equator, where warmer conditions supported plant growth. The spread of vegetation was closely connected to climate conditions, water availability, and the gradual development of soils. One important early forest plant was Archaeopteris. Although its name is similar to the early bird Archaeopteryx, they were completely different organisms. Archaeopteris was a tree-like plant that lived during the later Devonian period. It had a strong woody structure and produced leaves that helped it capture sunlight. It is considered one of the earliest examples of a large tree-forming plant. Archaeopteris forests spread across many parts of the ancient continents. These forests reached heights that were much greater than earlier land vegetation. Their presence created complex habitats, where many organisms could find protection and resources. The development of these forests represented a major change in the history of terrestrial ecosystems, because land environments became more suitable for larger animals. As forests expanded, they influenced the movement of carbon between the atmosphere, plants, soil, and oceans. Plants absorb carbon dioxide during photosynthesis, using sunlight to produce energy and releasing oxygen. The increasing number of large plants during the Devonian period removed significant amounts of carbon dioxide from the atmosphere. The reduction of carbon dioxide affected Earth's climate. Carbon dioxide is a gas that influences how much heat remains in the atmosphere. As plants became more widespread and stored more carbon in their tissues and underground materials, atmospheric conditions gradually changed. The climate began to experience changes that were connected to the growth of vegetation. The development of forests also increased the amount of oxygen in the atmosphere. During photosynthesis, plants release oxygen as a byproduct. As plant life expanded over millions of years, oxygen levels slowly increased. This created conditions that supported the evolution of larger and more active animals on land. The increase in plant life created new food sources for animals. Before forests existed, most land animals were small and depended on limited sources of food. The expansion of vegetation provided more opportunities for animals to live on land. Insects, early amphibians, and later reptiles began developing new ways to use these environments. Insects were among the first successful groups of animals to establish themselves on land. Their ancestors had already appeared before the Devonian period, but the growth of forests provided many new habitats where insects could diversify. Plants offered shelter, food, and places where insects could reproduce. During the Devonian and Carboniferous periods, insects developed many different forms. Some fed on plants, while others hunted smaller organisms. Many insects developed body structures that helped them move through vegetation, climb plant surfaces, and survive in different environments. The relationship between plants and insects became important during this period. As plants produced more leaves, stems, and other plant materials, insects gained new sources of food. In return, insects affected plant communities by feeding on plants and spreading plant material through different areas. The Carboniferous period, which followed the Devonian period, began around 359 million years ago and lasted until around 299 million years ago. During this time, forests expanded greatly across many regions of Earth. Large areas became covered with thick vegetation, especially in warm and wet environments near the equator. The Carboniferous forests contained many types of plants that are now extinct. These included giant club mosses, large horsetails, and seed ferns. Some of these plants reached great heights and formed extensive forests in swampy areas. These environments later contributed to the formation of many coal deposits because large amounts of plant material accumulated and were buried over long periods. The forests of the Carboniferous period were important because they created highly productive ecosystems. Large amounts of plant material supported many forms of life. The availability of food and shelter allowed insects and other land animals to become more diverse. During this period, insects reached impressive levels of diversity. Some insects grew much larger than most insects living today. The higher oxygen levels in the atmosphere may have contributed to the ability of some insects to reach larger sizes. One example was Meganeura, a giant dragonfly-like insect that lived during the Carboniferous period. Meganeura had a large wingspan and was a powerful flying predator. It hunted smaller insects and other small animals in the forest environment. Its existence shows how different insect communities became as forests expanded and atmospheric conditions changed. Other insects developed different lifestyles during this period. Some lived among plants, feeding on leaves and other plant parts. Others became predators that hunted other insects. Some insects developed early forms of social behavior, although the highly organized colonies seen in modern ants and bees developed much later. The growth of forests also affected amphibians. Amphibians had already evolved before the Devonian period, but they became more successful as land environments improved. Early amphibians descended from fish that developed the ability to move onto land. They had features that allowed them to breathe air and support their bodies outside water. The first land vertebrates evolved from certain fish groups that developed strong fins and other adaptations for movement in shallow water environments. Over time, some of these animals became capable of spending more time on land. They were not fully independent from water, but they represented an important stage in the movement of vertebrate life into terrestrial environments. The spread of forests provided amphibians with new habitats. Wet forests, rivers, and swamp environments offered suitable conditions for amphibian survival. Many amphibians depended on moist areas because their skin needed to remain wet, and they still reproduced through eggs that required water. During the Carboniferous period, amphibians became larger and more diverse. Some groups developed strong bodies and powerful limbs that allowed them to move through forest environments. They occupied different ecological roles, including predators that hunted insects, small animals, and other organisms. The development of early reptiles occurred during this period as well. Reptiles evolved from earlier amphibian-like ancestors and developed important features that allowed them to live farther from water. One major development was the amniotic egg, which protected embryos with a special covering and allowed reproduction on land. The appearance of the amniotic egg was a significant step in the history of land animals. It reduced dependence on water for reproduction and allowed early reptiles to explore drier environments. Their bodies also developed stronger skin that reduced water loss, helping them survive in areas where amphibians had difficulty living. Early reptiles remained relatively small during the Carboniferous period, but they represented a new direction in vertebrate evolution. They could move into environments that were not suitable for many amphibians. Over time, reptiles would become one of the most successful groups of land animals. The expansion of forests during the Devonian and Carboniferous periods created the conditions that supported these changes. Plants changed the physical environment by creating new habitats, producing oxygen, forming soils, and influencing climate patterns. Animals responded to these changes by developing new abilities and lifestyles. The connection between plants and animals became stronger as terrestrial ecosystems became more complex. Forests provided food and shelter, while animals influenced the growth and spread of plants. The development of these relationships shaped the future of life on land and established ecosystems that continued to change over hundreds of millions of years. The rise of early reptiles began during a major period of change in Earth's history, when life was expanding from water environments into wider areas of land. Around 320 million years ago, during the later part of the Carboniferous period, some groups of four-limbed animals began developing features that allowed them to live farther away from rivers, lakes, and wetlands. These early animals were related to amphibians, but they developed important changes that separated them from amphibian lifestyles. One of the most important developments was the evolution of the amniotic egg, a structure that allowed their young to develop on land instead of needing water for reproduction. Before reptiles appeared, amphibians were among the main groups of land vertebrates. Early amphibians had strong limbs that allowed them to move across land, but their reproduction remained closely connected to water. Most amphibians needed moist environments because their eggs did not have a protective covering that could prevent drying. Their eggs were usually laid in water, where the young developed through stages that included a larval form adapted for aquatic life. This connection to water limited where amphibians could successfully live because dry regions, open landscapes, and areas far from permanent water sources were difficult places for them to reproduce. The development of the amniotic egg changed this situation. The amniotic egg contained several protective layers that supported the growth of the developing embryo while it remained outside the body of the parent. These layers helped protect the embryo from drying out and provided important materials needed for development. The egg contained a fluid-filled space around the embryo, which created a suitable environment for growth. It also contained membranes that helped exchange gases, remove waste materials, and provide protection. The evolution of this egg was one of the most important changes in the history of land vertebrates. It allowed certain animals to reproduce in places where water was not always available. Parents no longer needed to return to ponds or streams to lay eggs. Instead, they could place their eggs on land in protected locations, such as soil, vegetation, or sheltered areas. This allowed their descendants to spread into many different environments. The first animals with amniotic eggs were not modern reptiles in the exact form seen today. They were early amniotes, a group that later produced reptiles, birds, and mammals. The earliest known amniotes developed from amphibian-like ancestors during the Carboniferous period. Fossils from this time show animals with features that indicate a transition towards a more land-based existence. One of the earliest known reptile-like animals was Hylonomus, which lived around 315 million years ago. Fossils of this small animal were discovered in ancient tree stump deposits in what is now Canada. Hylonomus had a lightweight body, strong limbs, and features that helped it survive in terrestrial environments. Its existence shows that early reptiles were already developing the ability to live independently from water. Early reptiles were generally small animals compared with many later reptiles. Their bodies were covered with scales that reduced water loss from their skin. This was another important feature that helped them survive in drier areas. Amphibians usually have thin, moist skin that allows gas exchange but causes them to lose water easily. Reptiles developed a more protective outer covering made of keratin, a strong material found in modern animal structures such as scales, claws, and hair. These scales reduced the amount of moisture escaping from their bodies. The combination of the amniotic egg and protective skin allowed early reptiles to move into environments that were unsuitable for many amphibians. They could survive in areas with lower humidity and fewer sources of standing water. Their bodies became better suited for life on land because they were less dependent on external water sources. During the Carboniferous period, large swamp forests covered many regions of Earth. These forests contained giant plants such as tree-sized ferns, club mosses, and horsetails. The environment was generally warm and humid in many areas, creating conditions where amphibians were successful. However, changes in climate began occurring towards the end of this period. Some regions became drier, and seasonal changes became stronger. These conditions created new opportunities for animals that could tolerate reduced moisture. The early reptiles that appeared during this time were able to occupy spaces where amphibians faced greater challenges. They moved through forests, dry woodland areas, and open landscapes. Their ability to lay eggs away from water allowed them to establish populations in new locations. The evolution of reptiles was not a sudden event. It happened through many generations as small changes accumulated. Early amniotes developed different body structures, behaviors, and reproductive methods that improved their survival on land. Natural selection favored individuals that could protect their eggs, conserve water, and move efficiently across terrestrial surfaces. The skull structure of early reptiles also changed over time. One important difference involved openings behind the eye area that affected the arrangement of skull bones and muscles. Early reptiles developed different skull patterns that later led to several major groups. These groups included animals that became ancestors of modern turtles, lizards, snakes, crocodiles, birds, and other reptiles. The earliest reptiles belonged mainly to two broad groups known as anapsids and diapsids. These groups were identified by differences in the openings and structures of their skulls. The anapsid group included early reptiles with solid skulls behind the eyes. Some scientists have historically connected this group with turtles, although the exact evolutionary position of turtles has been studied and debated because fossil evidence has revealed more complex relationships. The diapsid reptiles developed two openings behind each eye. This skull structure provided more space for jaw muscles and allowed different feeding adaptations to develop. Diapsids later produced many successful reptile groups, including dinosaurs, crocodiles, birds, lizards, and snakes. Another early reptile group was the synapsids, which developed from early amniotes and eventually produced mammals. Synapsids had a different skull opening behind the eye and developed their own evolutionary path. Their existence shows that the early reptile period was also a time when several major branches of land vertebrates were forming. The spread of early reptiles across ancient landmasses was closely connected to the arrangement of continents during the late Paleozoic era. Around 300 million years ago, many of Earth's continents were moving together and forming the large supercontinent known as Pangaea. This huge landmass created wide areas of connected land where terrestrial animals could move between regions. Because much of the land was connected, early reptiles had opportunities to expand into different environments. They could travel through forests, plains, and dry regions without needing to cross large ocean barriers. This helped reptile populations become established across wide areas. The movement of reptiles into new regions was also influenced by differences in local environments. Some groups adapted to warmer and drier areas, while others remained in forests and wetter habitats. Over time, different populations developed unique features because they faced different conditions and food sources. Early reptiles had several advantages that supported their expansion. Their eggs allowed reproduction away from water. Their scales reduced water loss. Their lungs were more effective than those of many amphibians because they were designed for breathing air throughout their lives. Their movements also became more efficient for traveling across land. The development of stronger limbs and improved body support helped reptiles move more effectively. Amphibians generally have bodies that require moist environments and often move with body movements connected to their swimming ancestry. Early reptiles developed stronger skeletal structures that supported their weight on land. Their feet and limbs became better suited for walking across solid surfaces. The spread of reptiles continued through the Permian period, which began around 299 million years ago. During this period, reptiles became more diverse and occupied many different habitats. The climate in many parts of the world became increasingly dry, and large areas changed from swamp environments into more open landscapes. These conditions supported animals that could survive with less water. Many early reptile groups remained small, but some developed specialized lifestyles. Some became active hunters, while others fed on plants or insects. Their body shapes, teeth, and movement patterns changed according to their food sources and environments. The development of plant communities also influenced reptile evolution. As forests changed and new types of vegetation appeared, animals that depended on these plants also changed. Insects became more diverse, creating new food sources for small reptiles. Larger plant-eating animals also developed, creating new ecological relationships on land. The transition from amphibian dominance to reptile expansion was connected to these environmental changes. Amphibians continued to exist and remain successful in many areas, especially those with abundant moisture. However, reptiles gained access to environments that required stronger adaptation to dry conditions. The amniotic egg remained one of the central features that separated reptiles and other amniotes from earlier land vertebrates. It allowed reproduction to become less dependent on bodies of water and supported the movement of animals into places that had previously been difficult to occupy. The Triassic period began about 252 million years ago and lasted until about 201 million years ago. It was the first period of the Mesozoic era and followed the Permian period, which ended with the largest known extinction event in Earth's history. At the beginning of the Triassic period, life on Earth had been greatly affected by the loss of many plant and animal groups. Many ecosystems had been damaged, and only some groups of organisms survived the harsh conditions that followed the extinction. The early Triassic world was a time of environmental change, recovery, and the development of new groups of animals that would later become important in Earth's history. The conditions of the early Triassic period were difficult for many surviving species. The climate was generally hot and dry in many regions because most of the continents had joined together into a large landmass called Pangaea. This large continent covered a wide area and affected weather patterns around the world. Many inland areas experienced extreme dryness because they were far from the oceans. Seasonal changes caused some areas to experience periods of heavy rainfall, followed by long dry periods. These environmental conditions influenced the types of plants and animals that could survive. The oceans during the early Triassic period were also recovering from major losses. Many marine organisms had disappeared during the Permian extinction, including many types of reef-building organisms and sea animals. The empty environments created opportunities for surviving groups to expand and for new species to develop. Over millions of years, marine ecosystems slowly became more complex as new animals appeared and adapted to different environments. On land, reptiles became increasingly important during the Triassic period. Before this time, several reptile groups already existed, but the environmental changes after the Permian extinction allowed some reptile groups to spread into new areas. These reptiles developed different body structures and ways of living. Some became plant eaters, while others became active hunters. Among these reptile groups were the ancestors of dinosaurs, crocodiles, and birds. The first dinosaurs appeared during the early part of the Triassic period, around 233 million years ago. They evolved from a group of reptiles known as archosaurs. Archosaurs were a larger group of reptiles that also included the ancestors of crocodiles and birds. Early dinosaurs were not immediately the dominant animals on land. They were relatively small and lived alongside many other reptiles that were common during this period. The earliest dinosaurs had body features that helped them move efficiently on land. Their legs were positioned beneath their bodies rather than extending outward from their sides. This body structure allowed them to walk and run with greater control. Many early dinosaurs were lightweight animals with long tails that helped them maintain balance while moving. Their bones were often hollow, which reduced their body weight while still providing support. One of the earliest known dinosaurs was Eoraptor, which lived approximately 231 million years ago in what is now South America. It was a small dinosaur with a slender body and sharp teeth. It likely ate a combination of small animals and plant material. Its discovery helped scientists understand the early stages of dinosaur evolution. Another early dinosaur was Herrerasaurus, which lived during the late Triassic period. It was larger than many other early dinosaurs and had features associated with meat-eating animals. It had strong jaws, sharp teeth, and a body designed for active movement. Fossils of Herrerasaurus were found in Argentina, showing that early dinosaurs had already spread across parts of the ancient southern continents. During the Triassic period, dinosaurs were only one group among many reptiles. Other archosaurs and reptile groups were also widespread. Animals related to crocodiles, known as pseudosuchians, were especially successful during much of the Triassic period. Some of these animals were small and walked on land, while others became large predators. They occupied many environments and were important members of Triassic ecosystems. The ancestors of modern crocodiles developed during this period. These early crocodile relatives were different from modern crocodiles in many ways. Some walked on two legs, while others had body shapes suited for hunting on land. They included a variety of species with different lifestyles. Some were large predators that hunted other animals, while others may have eaten plants or smaller creatures. A major group of early crocodile relatives was the group called pseudosuchians. These animals belonged to the archosaur family and had strong legs, powerful jaws, and protective body coverings in many species. Some developed large bodies and became among the top predators of Triassic environments. Their success shows that crocodile relatives were highly diverse during this period. One example of an important Triassic crocodile relative was Postosocus. It lived around 220 million years ago and was a large predator. It had a strong skull, sharp teeth, and powerful limbs. Scientists believe it hunted other animals and played an important role in its ecosystem. Marine reptiles also developed and expanded during the Triassic period. As ocean ecosystems recovered, several groups of reptiles adapted to life in the sea. These animals developed features that allowed them to swim, hunt, and survive in marine environments. They were not dinosaurs, but they were important reptiles that lived at the same time as early dinosaurs. One important group of marine reptiles was the ichthyosaurs. These animals appeared during the early Triassic period and became highly adapted for swimming. They had streamlined bodies, strong tails, and large eyes. Some ichthyosaurs had bodies that looked similar to modern fish because their shape helped them move through water efficiently. They hunted fish and other marine animals. Ichthyosaurs were among the first successful marine reptiles after the Permian extinction. Their fossils show that they quickly adapted to ocean environments. Some species became large predators with powerful jaws and many teeth. They lived in oceans around the world and remained important marine animals for millions of years. Another group of marine reptiles that developed during the Triassic period was the nothosaurs. These animals were adapted for life in shallow coastal waters. They had long bodies, strong limbs, and flexible necks. Some species may have hunted fish and other small marine creatures near the coast. Their fossils have been found in areas that were once covered by ancient seas. The plesiosaurs also began appearing during the Triassic period. These reptiles had broad bodies, long necks, and strong flippers that helped them move through the water. They became important marine predators in later periods of the Mesozoic era. Their early development during the Triassic shows the expansion of different reptile groups into marine environments. The recovery of life after the Permian extinction created many opportunities for new animals to develop. The Triassic period was a time when many reptile groups explored different ways of living. Some became land predators, some became plant eaters, and others adapted to oceans. These changes shaped the development of ecosystems for millions of years. The rise of dinosaurs happened slowly during the Triassic period. Early dinosaurs lived alongside many other successful reptiles, and they were not the largest or most common animals at first. Their early history involved gradual changes in body structure, movement, and feeding habits. Over time, different dinosaur groups developed specialized features that allowed them to survive in various environments. The first dinosaurs belonged mainly to two major groups based on their hip structure. These groups later developed into many different forms during the Jurassic and Cretaceous periods. Early members of these groups included small meat-eating dinosaurs and early plant-eating dinosaurs. Their fossils provide evidence of the gradual changes that occurred during this Triassic period. Plant-eating dinosaurs began developing during the late Triassic period. These early herbivorous dinosaurs had teeth and body structures suited for eating plants. They helped introduce new feeding patterns into terrestrial ecosystems. Some later evolved into much larger dinosaur groups that became common in later periods. Small meat-eating dinosaurs were also present during the Triassic period. They were active hunters that fed on small animals. Their lightweight bodies and strong legs allowed them to move quickly. Some had grasping hands and sharp claws that helped them capture prey. The environment of the Triassic period contained many types of animals besides dinosaurs, crocodile relatives, and marine reptiles. Amphibians, insects, early turtles, and many reptile groups continued to exist. Plants such as ferns, cycads, and conifers provided food and shelter for many animals. These plants formed the foundation of many land ecosystems during this time. The development of the first mammals also began during the Triassic period. Mammals evolved from a group of reptiles called synapsids, which had already existed since the late Paleozoic era. Synapsids included many different animals, including the ancestors of mammals. After the Permian extinction, some surviving synapsids continued to evolve new features. The first true mammals appeared around 225 million years ago, during the late Triassic period. They evolved from small advanced synapsids known as mammaliaforms. These early mammals were very small animals, often similar in size to modern small rodents. They lived alongside dinosaurs and other reptiles. Early mammals developed several important features that separated them from earlier synapsids. They had specialized teeth that could perform different functions, including cutting and grinding food. They also had changes in their jaw structure that later became important in mammal evolution. Their bodies were covered with hair, and they likely had the ability to maintain a stable body temperature. One early mammal-like animal was Morganucodon. It lived near the end of the Triassic period and had many features associated with early mammals. It was a small animal that probably fed on insects and small prey. Fossils of Morganucodon have helped scientists study the early stages of mammal development. The first mammals lived in a world dominated by reptiles. They survived by occupying smaller ecological roles and adapting to specific environments. Many early mammals were active at night, which may have helped them avoid competition with larger daytime animals. Their small size and flexible diets allowed them to survive through changing conditions. The Triassic period continued to experience changes in climate, geography, and ecosystems. New animal groups continued to develop while older groups disappeared. The appearance of early dinosaurs, crocodile relatives, marine reptiles, and the first mammals represented important developments in the history of life on Earth. The Permian period began about 299 million years ago and lasted until about 252 million years ago. It was the final period of the Paleozoic era and was a time when the surface of Earth experienced major changes. During this period, the continents that had once been separated by large oceans slowly moved toward each other. Over millions of years, these movements caused many land areas to join together and form a single large continent known as Pangaea. The formation of this enormous landmass changed the climate, affected the movement of oceans, influenced the development of plants and animals, and created new environments where many groups of living things evolved. The movement of continents during the Permian period was controlled by the slow activity of Earth's tectonic plates. The outer part of Earth is divided into large pieces called tectonic plates. These plates move very slowly because of heat and movement deep inside Earth. Although their movement is usually only a few centimeters each year, over millions of years, these small movements can change the arrangement of continents across the planet. Before the Permian period, Earth's continents were already moving toward one another. During the earlier Carboniferous period, many continental blocks began coming together. Large land areas that had been separated by oceans gradually approached each other. By the beginning of the Permian period, much of the land had already joined, and this process continued until most of the continents became connected into Pangaea. The name Pangaea comes from ancient Greek words meaning all earth. It describes the large continental mass that contained most of the planet's land. Pangaea was surrounded by a huge ocean called Panthalassa. Another important ocean area, known as the Paleotethys Ocean, existed near the eastern side of the continent. The arrangement of land and water during this time was very different from the arrangement of continents today. The formation of Pangaea did not happen suddenly. It took many millions of years for the separate continents to move into position. Areas that are now parts of Africa, South America, North America, Europe, Asia, Antarctica, and Australia were connected within this large continental system. The joining of these land areas created a massive interior region far away from ocean influence. Several major continental collisions took place during this process. The collision between the northern continents and southern continents created large mountain systems. When two continental plates pushed against each other, the rocks at the edges of the plates were compressed, folded, and lifted upward. These geological events produced mountain ranges that existed during the Permian period and affected the landscape of Pangaea. One important collision involved the northern continent known as Laurussia, which included areas that later became North America and parts of Europe, joining with the southern supercontinent known as Gondwana. Gondwana contained the land that later became South America, Africa, Antarctica, Australia, and the Indian subcontinent. The joining of these regions helped create the central structure of Pangaea. The movement of India was also important. During this period, India was part of Gondwana and was located farther south during the Permian period. It was connected with other southern land areas and would continue moving northward millions of years later. The positions of these land areas affected ocean currents, climate patterns, and the distribution of living organisms. As Pangaea formed, many shallow seas that had existed between smaller continents disappeared. The closing of these seas changed the environments available for marine life. Some coastal areas became larger land regions, while other marine habitats were reduced. Many organisms that depended on specific, shallow water environments experienced changes in their living conditions. The creation of Pangaea also changed the shape and size of coastlines. Earlier periods had many separate continents, with long coastlines exposed to oceans. During the Permian period, the joining of continents reduced the total amount of coastline. This affected the number of coastal habitats available for marine organisms and changed the places where many species could survive. The interior of Pangaea developed conditions that were different from coastal areas. Because the center of the continent was located far from oceans, moisture from the sea had difficulty reaching these regions. Large parts of central Pangaea became dry environments with lower rainfall. Seasonal changes became stronger, with some areas experiencing very hot periods and long dry seasons. The climate of Pangaea was not the same everywhere. The southern regions near the South Pole remained cold, and some areas still contained ice sheets. During the early part of the Permian period, these cold conditions were connected to the remains of the large Gondwanan ice sheets that had developed during the late Carboniferous period. Over time, the climate became warmer, and many of these ice-covered regions gradually disappeared. The northern and central areas of Pangaea experienced increasing dryness. The large size of the continent allowed extreme differences between inland and coastal climates. Areas near the edges of the continent received more influence from oceans, while the interior areas became more isolated from ocean moisture. The changing climate affected plant life across Pangaea. During earlier periods, large swamp forests had covered many areas and produced the plant material that later became coal deposits. During the Permian period, these widespread wet forests declined in many regions because conditions became drier. Plants that could survive in dry environments became more common. Seed plants became increasingly important during the Permian period. Plants such as conifers, seed ferns, and other groups with adaptations for drier conditions spread across many parts of Pangaea. Unlike many earlier plants that depended heavily on wet environments for reproduction, seed plants could reproduce in areas with less available water. The spread of seed plants changed terrestrial ecosystems. Forests became different in structure, and new habitats developed for land animals. Plant communities provided food and shelter for many herbivorous animals, which then supported the development of new predator groups. The formation of Pangaea affected the movement and distribution of animals. When continents joined together, animals that had previously been separated by oceans could move across larger areas of land. This allowed some groups to spread into new regions. At the same time, changing climates created barriers that prevented some species from surviving in certain areas. During the Permian period, many new animal groups developed and expanded on land. Among the most important were synapsids, a group of animals that included early relatives of mammals. These animals developed different body forms and lifestyles and became some of the dominant land animals during parts of the Permian period. Early synapsids included small insect-eating animals, as well as larger plant-eating and meat-eating forms. Some members of this group developed large bodies and strong jaws, allowing them to hunt other animals or consume tough plant material. Their development showed important changes in the evolution of land vertebrates. One well-known group of synapsids was the pelycosaurs. They appeared earlier during the late Carboniferous period, but became widespread during the early Permian period. Some pelycosaurs had large structures on their backs made of extended spines covered with skin. These animals lived in different environments across Pangaea and included both predators and plant eaters. Later in the Permian period, another group called therapsids became more successful. Therapsids had features that were closer to those of later mammals. They developed stronger legs, changes in their skull structure, and different methods of feeding. Some therapsids became among the most common land animals before the end of the Permian period. The development of new animal groups was not limited to land. The oceans of the Permian period also contained many forms of life. Marine ecosystems continued to change as ocean environments were affected by continental movement, climate changes, and changes in sea levels. Fish groups continued to live in Permian oceans, including sharks, ray-finned fish, and other early fish groups. Many marine reptiles also began appearing during this period. These reptiles developed adaptations that allowed them to live and hunt in ocean environments. Early marine reptiles included groups such as mesosaurs, which lived in freshwater and coastal environments. Later marine reptile groups became more specialized and developed during the Permian period and the following periods. Their appearance showed that reptiles were expanding into different habitats. Amphibians were still present during the Permian period, but many groups were affected by the drying climate. Amphibians generally required moist environments because their reproduction depended on water. As many regions became drier, some amphibian groups declined while others survived in suitable habitats. Insects also continued to diversify during the Permian period. Different insect groups developed new feeding methods and relationships with changing plant communities. The spread of seed plants created new sources of food and new environments where insects could live. The formation of Pangaea influenced all these changes by creating new connections between environments. Animals and plants were able to spread across larger areas, but they also faced new conditions created by dry climates, changing temperatures, and altered landscapes. The movement of continents shaped the biological history of the Permian world. The Permian period was a time of major geological activity, environmental change, and biological development. The creation of Pangaea transformed the arrangement of Earth's continents and changed the conditions under which life developed. The movement of land, the changing climate, and the evolution of new animal groups were closely connected parts of this long period in Earth's history. The Permian-Triassic mass extinction was one of the most important events in the history of life on Earth. It happened around 252 million years ago at the boundary between the Permian period and the Triassic period. During this event, a very large number of plants, animals, and marine organisms disappeared from the planet. Scientists study this extinction because it changed the direction of life on Earth and affected ecosystems that had developed over millions of years. Before the extinction happened, the Earth was in the late Permian period. The planet had a wide variety of living organisms in oceans and on land. Large forests existed in many regions, and many groups of reptiles, amphibians, and early relatives of mammals lived across the continents. The oceans contained many types of fish, shell-forming animals, coral communities, and other marine life. These ecosystems had developed slowly through a long period of evolution, but several powerful environmental changes occurred that placed great pressure on living organisms. The Permian-Triassic extinction is known as the largest known extinction event in Earth's history. A large percentage of marine species disappeared, and many land animals and plants were also lost. The exact number of extinct species is still studied by scientists, but evidence from fossils shows that the extinction affected most major groups of life that existed at that time. The event was not caused by a single, simple factor. Instead, several connected changes occurred, including massive volcanic activity, rising temperatures, changes in the atmosphere, ocean damage, and changes in natural environments. One of the main causes connected to the extinction was a period of enormous volcanic activity in the region that is now known as Siberia. This volcanic activity created the Siberian Traps, a large area formed from repeated volcanic eruptions. These eruptions released huge amounts of volcanic rock, gases, and other materials into the environment over a long period. The activity continued for hundreds of thousands of years and caused major changes to the Earth's climate and atmosphere. When volcanoes erupted on such a large scale, They release gases including carbon dioxide and sulfur compounds. Carbon dioxide is a gas that affects the temperature of the planet because it can trap heat in the atmosphere. Large amounts of carbon dioxide entering the atmosphere caused global temperatures to rise. The warming affected both land and oceans, creating difficult conditions for many species that were adapted to earlier climates. The volcanic eruptions also released sulfur gases that could affect weather patterns and chemical conditions in the atmosphere. These gases could create periods of cooling when volcanic particles blocked sunlight. But the long-term effect of the volcanic activity was a strong increase in global temperatures. The repeated release of gases continued to disturb the balance of Earth's environment. The warming of the planet caused major changes in rainfall patterns. Some areas became much drier, while others experienced different weather conditions than before. Plants that depended on specific climates struggled to survive in changing environments. Since plants formed the foundation of many food systems, the decline of plant communities affected many animals that depended on them for food and shelter. The increase in global temperatures also had a serious effect on the oceans. Ocean temperatures rose, and warmer water held less oxygen than colder water. This caused many areas of the oceans to lose oxygen, creating conditions known as ocean anoxia. Ocean anoxia made it difficult for many marine animals to survive because they needed oxygen-rich water. The oceans during the late Permian period contained many organisms that depended on stable conditions. Marine ecosystems included corals, brachiopods, mollusks, sea creatures related to modern starfish, and sea urchins, and many types of fish. When ocean conditions changed, many of these organisms could not adapt quickly enough. The loss of these species affected food relationships throughout marine environments. Another major problem caused by volcanic activity was ocean acidification. When large amounts of carbon dioxide entered the atmosphere, some of it was absorbed by the oceans. This changed the chemistry of seawater and made it more acidic. Many marine organisms built shells or skeletons using minerals that were affected by increasing acidity. Changes in ocean chemistry made it harder for these organisms to grow and survive. The extinction also involved changes to the atmosphere itself. During the late Permian period, Earth's atmosphere had different conditions from today. The increase of greenhouse gases caused temperatures to rise beyond the levels that many species could tolerate. Some scientists have also suggested that changes in methane release may have increased warming. Methane is a gas that can strongly affect climate when present in large amounts. The collapse of ecosystems did not happen instantly everywhere. Different environments were affected at different times. Some species began declining before the main extinction period, while others disappeared during the most severe environmental changes. Fossil records show that many groups survived for some time before finally becoming extinct as conditions continued to worsen. On land, the extinction affected many important animal groups. The late Permian world contained many types of synapsids, which were a group of animals related to the ancestors of mammals. Some synapsids were large plant eaters, while others were predators. Many of these animals disappeared during the extinction. Some smaller synapsids survived and later gave rise to new groups during the Triassic period. Early reptiles were also affected. Many reptile groups that had existed for millions of years disappeared or became greatly reduced. The loss of these animals changed the structure of terrestrial ecosystems. New groups of reptiles later became more common during the Triassic period, but the communities that existed before the extinction were greatly altered. Amphibians experienced major losses as well. Many amphibian species depended on specific environmental conditions, especially areas with enough water and suitable temperatures. Climate changes, habitat destruction, and changes in freshwater environments contributed to their decline. Some amphibian groups survived, but many others disappeared. Plants were also affected by the environmental changes. Fossil evidence shows that many plant communities changed during the extinction period. Forest ecosystems declined in many areas, and some regions experienced major changes in vegetation. The disappearance of plant species affected animals because plants provided food and created habitats for many organisms. Marine life suffered some of the greatest losses. Many groups of brachiopods, which were shell-bearing marine animals, disappeared. Several types of coral communities were destroyed. Many ancient reef ecosystems collapsed because the organisms that built and maintained them could not survive the changing ocean conditions. Trilobites, which were one of the most successful groups of marine animals in earlier periods, had already declined before the late Permian period. The final surviving trilobite species disappeared during the Permian-Triassic extinction. Their disappearance marked the end of a group that had existed for more than 300 million years. Many other marine invertebrates also suffered severe losses. Groups of mollusks, sea animals with shells, and other ocean organisms declined greatly. The disappearance of these animals changed marine food systems because many predators depended on them for survival. The extinction also affected large predators. When prey species disappeared, predators that depended on those animals faced serious challenges. A reduction in available food caused many predator populations to decline. The changes spread through ecosystems because living organisms were connected through feeding relationships and environmental needs. The collapse of ecosystems was made worse because environmental recovery took a very long time. After the extinction, many ecosystems remained unstable. The early Triassic period had fewer species than the late Permian period, and many environments were dominated by only a limited number of surviving organisms. The causes behind the extinction continue to be studied because the event involved many complicated processes. Scientists use fossils, rocks, chemical evidence, and climate information preserved in ancient layers of Earth to understand what happened. Rock layers from the Permian-Triassic boundary contain evidence of changes in carbon levels, ocean conditions, volcanic materials, and the disappearance of many fossil species. The Siberian traps remain one of the strongest pieces of evidence connected to the extinction. The scale of the volcanic activity was extremely large, and scientists have found that it occurred around the same time as the major biological losses. The release of volcanic gases created environmental changes that affected both land and sea ecosystems. The volcanic eruptions have also affected the carbon cycle. Large amounts of carbon entered the atmosphere and oceans, changing natural systems that normally regulate climate. These changes created long-lasting effects on temperatures, ocean chemistry, and living conditions. The extinction event also shows how closely connected different parts of Earth's environment are. Changes in the atmosphere influenced the oceans. Changes in the oceans affected marine organisms, and the loss of plants and animals affected ecosystems on land. The environmental problems occurred together and increased the difficulty for many species to survive. The disappearance of many prehistoric species during the Permian-Triassic extinction changed the course of evolution. Groups that had been common for millions of years became rare or vanished completely. Other surviving groups later expanded during the Triassic period as new environments became available. The period after the extinction was a difficult time for life. Many habitats were damaged, and ecosystems needed a long period to recover. Some areas had low biodiversity, meaning they contained fewer different types of organisms. The recovery of forests, oceans, and animal communities happened gradually as environmental conditions improved. The Permian-Triassic mass extinction remains an important subject in paleontology and earth science, because it provides information about how natural systems respond to major environmental changes. The fossils from this period preserve evidence of a time when many ancient ecosystems were disrupted and many prehistoric species disappeared. The Jurassic period began about 201 million years ago and continued until about 145 million years ago. It was a major period in the history of life on Earth because many groups of dinosaurs became more widespread, larger, and more successful during this time. The environment of the Jurassic world changed greatly after the end of the Triassic period, when many species disappeared during a major extinction event. The disappearance of many earlier animals created new opportunities for surviving groups to develop and spread across the land, oceans, and skies. During the Jurassic period, the continents were arranged differently from their current positions. A large landmass called Pangaea had started breaking apart during the late Triassic period, and this process continued throughout the Jurassic. The movement of continents created new land areas, shallow seas, and different environments where plants and animals could develop. The climate in many regions was warm and supported the growth of large forests. There were no permanent polar ice sheets, and many areas had conditions that allowed plants to grow throughout much of the year. The forests of the Jurassic period contained many types of plants that provided food and shelter for numerous animals. Ferns, cycads, conifers, and other ancient plants covered large areas of land. These plants formed important sources of food for many herbivorous dinosaurs. The growth of large forests provided the necessary conditions for the development of some of the biggest land animals that ever lived. The availability of plant material allowed large herbivores to increase in size and become common across many regions. One of the most important groups of dinosaurs during the Jurassic period was the sauropods. Sauropods were long-necked, long-tailed dinosaurs with large bodies and strong legs. They included some of the largest animals known from the fossil record. These dinosaurs had small heads compared with the size of their bodies, long necks that helped them reach vegetation, and large stomachs that allowed them to process large amounts of plant material. Early sauropods had already appeared during the Triassic period, but they became much more successful during the Jurassic period. Their bodies continued to develop, and many species reached enormous sizes. Fossils from this period show that some sauropods grew to lengths of more than 20 meters and reached very high body weights. Their growth was supported by the rich plant life available in Jurassic environments. Sauropods developed several features that helped them survive. Their long necks allowed them to reach leaves from tall trees and plants without moving their entire bodies. Their strong legs supported their heavy bodies, allowing them to travel across wide areas in search of food and water. Their tails helped with balance as they moved. Their large bodies also provided protection, because many predators found it difficult to attack fully grown individuals. Some well-known Jurassic sauropods included Diplodocus, Brachiosaurus, and Apatosaurus. These dinosaurs lived in different regions and had different body structures. Diplodocus had an extremely long tail and neck, while Brachiosaurus had longer front legs that gave its body a raised shape. Apatosaurus had a large body supported by strong limbs and lived in environments where plenty of plant material was available. The feeding habits of sauropods influenced the structure of Jurassic ecosystems. Because they consumed large amounts of vegetation, they affected plant growth and the movement of nutrients through the environment. Their movement across forests and open areas changed the landscape by breaking plants, spreading seeds, and creating pathways through vegetation. Their waste also returned nutrients to the soil, supporting plant growth. Sauropods were not the only large herbivorous dinosaurs of the Jurassic period. Other plant-eating dinosaurs developed different body forms and ways of feeding. Some groups had defensive structures that helped protect them from predators. The development of different herbivore groups created a variety of plant-eating animals that occupied different parts of the environment. The Stegosaurus appeared during the later part of the Jurassic period. It was known for the large plates along its back and the spikes on its tail. These features were important parts of its body structure. Stegosaurus had a small head, a large body, and a low feeding position that allowed it to eat plants close to the ground. Its body design helped it live in environments where different types of vegetation were available. The spread of large herbivorous dinosaurs affected the development of predator species. As herbivorous dinosaurs increased in size and number, predators also developed new abilities to hunt them. The Jurassic period saw the rise of powerful theropod dinosaurs, a group that included many meat-eating species. Theropods had strong jaws, sharp teeth, powerful legs, and active hunting behaviors. Theropods had existed since the Triassic period, but during the Jurassic they became more diverse. Some remained small and fast-moving, while others became large predators capable of attacking very large animals. Their development was connected to changes in their bodies, hunting methods, and interactions with other animals. One of the most famous Jurassic predators was Allosaurus. It lived approximately 150 million years ago and was one of the largest predators of its time. Allosaurus had a large skull filled with sharp teeth, powerful jaws, and strong hind limbs. Its body was built for active movement, allowing it to chase and attack other dinosaurs. Allosaurus lived in areas where large herbivorous dinosaurs were common. Fossils show that it shared environments with sauropods and other plant-eating dinosaurs. This relationship created a setting where predators and prey interacted regularly. Allosaurus may have hunted young or weakened animals, although evidence suggests that it was capable of attacking different types of prey. The skull of Allosaurus had features that separated it from many other theropods. Its jaws could open widely, and its teeth were designed for cutting through flesh. Its neck muscles helped it move its head during feeding. Its arms had 3 fingers with claws that may have helped it hold onto prey. Other theropods also lived during the Jurassic period. Some were smaller and faster, using speed and movement to catch smaller animals. Others developed stronger bodies and larger skulls. The variety of theropods shows that meat-eating dinosaurs occupied many different roles within Jurassic ecosystems. The evolution of theropods was not only connected to hunting large herbivores. These dinosaurs also adapted to different habitats and food sources. Some hunted small reptiles, early mammals, and other dinosaurs. Their ability to use different resources helped them survive in changing environments. During the Jurassic period, ecosystems became more complex because many different organisms lived together. Plants, insects, reptiles, dinosaurs, and early mammals formed connected communities. Each group had a role in the environment, and changes affecting one group could influence others. The Jurassic forests contained many layers of plant life. Tall trees formed upper areas where some animals could find food, while smaller plants covered the ground. Ferns and other low-growing plants provided food for many herbivores. Insects helped with plant reproduction and served as food for smaller animals. Reptiles and amphibians lived in rivers lakes, and forest areas. Water environments also changed during the Jurassic period. Many regions had shallow seas where marine reptiles and other sea animals lived. Oceans contained large reptiles such as ichthyosaurs and plesiosaurs, along with many types of fish and invertebrates. These marine ecosystems developed alongside the land environments and supported a wide range of life. The separation of continents created different habitats around the world. Some dinosaur groups became restricted to certain regions, while others spread across large areas. Fossil discoveries from Europe, North America, Africa, and Asia show that Jurassic dinosaurs lived in many parts of the world. The expansion of forests provided stable food supplies for many herbivorous dinosaurs. Large dinosaurs required huge amounts of energy to support their bodies, and the continued growth of plant communities allowed these animals to survive. The presence of different plant types also allowed different herbivores to develop different feeding methods. The bodies of large herbivorous dinosaurs contained special features that supported their size. Many sauropods had hollow spaces in their bones, which reduced weight while maintaining strength. Their long necks allowed them to collect food from a wide area. Their digestive systems were designed to process large amounts of plant material over time. The growth of giant dinosaurs during the Jurassic period was connected to many environmental conditions. Warm temperatures, large forests, and changing continents created habitats where these animals could spread. The development of new dinosaur groups continued as ecosystems became more diverse. The Jurassic period also saw important changes among smaller animals. Early mammals continued to develop, although they remained small and were not the dominant land animals. They lived alongside dinosaurs and occupied different environments. Some lived in forests, some stayed close to the ground, and others developed specialized feeding habits. Bird-like characteristics also began appearing among certain dinosaur groups during the Jurassic period. Some theropods developed feathers and body features connected with later bird evolution. These changes occurred gradually over millions of years as different dinosaur groups developed new traits. The forests and ecosystems of the Jurassic period were shaped by constant interactions between plants and animals. Large herbivores influenced vegetation, predators influenced animal populations, and smaller organisms supported the wider ecosystem. Fossils from this period provide evidence of these relationships and show the variety of life that existed during this time. The Cretaceous period was a major period in Earth's history that lasted from about 145 million years ago to 66 million years ago. It was the final period of the Mesozoic era, a time when dinosaurs were widespread across many parts of the world. During this period, the Earth experienced many important changes in climate, geography, plants, and animals. The land areas, oceans, and living communities changed over millions of years, creating new conditions for many species to develop. At the beginning of the Cretaceous period, dinosaurs were already well established in many regions. Large plant-eating dinosaurs continued to live in different environments, while many meat-eating dinosaurs developed new features that helped them survive. The world was not the same as it had been during the earlier Jurassic period. Continents continued to move, seas changed in size and location, and new types of plants began to appear. These changes affected the animals that depended on these environments. One of the most important developments during the Cretaceous period was the spread of flowering plants. Before this time, many landscapes were dominated by plants such as conifers, ferns, cycads, and other ancient plant groups. Flowering plants, also known as angiosperms, began appearing during the early part of the Cretaceous period. and gradually became more common. These plants produced flowers and fruits, which created new sources of food for many animals. The rise of flowering plants changed many land environments. New plant communities developed in forests, open areas, and places near rivers and lakes. Different insects became closely connected with these plants because many insects helped with pollination. As flowering plants spread, they supported the growth of new ecosystems, where many types of animals could find food and shelter. The development of flowering plants also influenced dinosaur life. Many plant-eating dinosaurs adapted to environments where new types of vegetation were available. Dinosaurs that fed on plants developed different teeth, jaws, and body structures that helped them process various kinds of plant material. The availability of new plants allowed some herbivorous dinosaurs to survive in changing habitats. During the Cretaceous period, continents were slowly moving toward their modern positions. The large landmass known as Pangaea had already begun breaking apart during earlier periods, and this process continued. North America, South America, Africa, Europe, Asia, Australia, and Antarctica gradually separated. The movement of continents created new coastlines, mountain ranges, and isolated environments. The separation of land areas affected the distribution of dinosaurs and other animals. Groups that became separated from each other could develop different features over many generations. Dinosaurs living in one region could experience different climates and food sources from dinosaurs living in another region. This helped produce many different dinosaur groups around the world. The climate during the Cretaceous period was generally warmer than the present day. There were no permanent ice sheets at the poles, and sea levels were often higher than today. Large shallow seas covered parts of continents, creating coastal environments where many marine animals lived. Warm temperatures allowed forests and plant communities to exist in areas that are now much colder. The oceans of the Cretaceous period contained many types of life. Marine reptiles such as mosasaurs and plesiosaurs lived in the seas, while ammonites, sharks, and many types of fish were common. These animals occupied different areas of the oceans and formed complex food systems. Changes in sea levels created new marine habitats and affected where these animals could live. On land, dinosaurs remained the dominant large animals. However, the Cretaceous period was not only a time of large dinosaurs. Many smaller reptiles, mammals, insects, and birds also developed during this period. These smaller animals played important roles in ecosystems and continued to evolve alongside dinosaurs. The evolution of advanced dinosaur groups was one of the major features of the Cretaceous period. Many dinosaur families that became well known developed during this time. These included tyrannosaurs, ceratopsians, hadrosaurs, ankylosaurs, and many types of small feathered dinosaurs. Among the most important groups were the theropods. Theropods were mostly meat-eating dinosaurs that walked on two legs. Early theropods appeared much earlier, but during the Cretaceous period, many advanced forms developed. Some became large predators, while others became smaller animals with feathers and bird-like features. The tyrannosaurs were among the most successful large theropod dinosaurs of the late Cretaceous period. Members of this group had strong jaws, powerful legs, and large skulls. The most famous member of this group was Tyrannosaurus rex, which lived in parts of western North America about 68 million to 66 million years ago. It had a large head filled with strong teeth and a body adapted for hunting and feeding. Other theropod groups developed in different parts of the world. In Africa and South America, large predators such as abelisaurids lived. These dinosaurs had different skull shapes and body structures from tyrannosaurs. In Asia and other regions, dinosaurs such as dromaeosaurs and troodontids developed. Many of these smaller theropods had feathers and showed features connected to the evolution of birds. The evolution of feathers was an important development among theropod dinosaurs. Fossil discoveries have shown that many dinosaur groups had feathers or feather-like coverings. Feathers were not only connected with flight, they may have helped with body temperature control, display and communication. Over time, some small feathered dinosaurs developed features that allowed the first birds to appear. Plant-eating dinosaurs also experienced major changes during the Cretaceous period. Hadrosaurs, often called duck-billed dinosaurs, became widespread in many parts of the world. They had specialized teeth arranged in large groups that helped them grind plant material. Some had large structures on their heads that may have been used for producing sounds or communication. Ceratopsians were another important group of Cretaceous herbivores. These dinosaurs had strong beaks, large bodies, and structures around their heads. Some developed large horns and bony frills. The well-known Triceratops lived near the end of the Cretaceous period in North America and had a large skull with 3 horns. Ankylosaurs were heavily built plant-eating dinosaurs that developed strong body protection. Many had bony plates within their skin, and some had powerful structures at the ends of their tails. These features helped protect them from predators. They lived in different regions and adapted to various environments. The Cretaceous period also saw the growth of giant sauropods in some areas. Sauropods were long-necked plant-eating dinosaurs that had existed since the Jurassic period. During the Cretaceous period, some groups such as titanosaurs became especially successful. Titanosaurs lived on several continents and included some of the largest land animals known from the fossil record. Titanosaurs had long necks, large bodies, and strong legs. Some species developed body structures that helped support their enormous size. They lived in many environments and survived until the end of the Cretaceous period. Fossils of these dinosaurs have been found in places including South America, Africa, Asia, and Europe. The development of new habitats during the Cretaceous period was closely connected with changes in plants and geography. Forests became more diverse as flowering plants spread. Grasslands as they exist today had not yet developed, but open areas with different plant communities appeared. Rivers, wetlands, forests, and coastal regions supported different groups of animals. Small animals also benefited from these changing environments. Mammals, although still generally small compared with dinosaurs, continued to evolve. Different groups developed new feeding methods and body features. Some mammals lived in trees, some lived on the ground, and some developed specialized diets. The Cretaceous period was also important for the development of modern animal lineages. Many groups that exist today have ancestors that lived during this time. Birds developed from small feathered theropod dinosaurs, while many modern insect groups and fish groups, reptiles and mammals continued their evolutionary changes. The first true birds appeared before the Cretaceous period, during the Jurassic period, but birds continued to diversify during the Cretaceous. They developed different body shapes, feeding methods and flying abilities. Some early birds had teeth, while later groups developed features that became more similar to modern birds. The evolution of birds was connected to changes in small theropod dinosaurs. Over many generations, some theropods developed lighter skeletons, modified arms, feathers, and changes in their bodies that supported flight. These changes did not happen suddenly, but developed gradually through many stages. During the Cretaceous period, birds lived in many environments. Some lived near oceans, some lived in forests, and others lived in inland areas. They competed with other small animals for food and survived alongside dinosaurs, mammals and reptiles.